Okay, a little introduction to Success Bridge. Okay, we are from the industry, from semiconductor, and we want to give a good exposure to all the upcoming engineers and enthusiasts who has done their engineering from the academics, and they want to enter into semiconductor. So we are filling the gap between the academics to the industry, because semiconductor is a it's a complete industry oriented courses that we deliver, and these courses has to be trained. Everyone has to go through these courses because industry will not welcome untrained professionals or directly from the academics, because the tools that we use are so expensive that academic colleges or the universities cannot afford the industry tools. So we at Success Bridge try to fill the gap between the academics and the industry, so that everybody can learn the industry real-time course and get into the semiconductor. So we have a strong vision to recognize a leader in the industry, and we want to provide knowledge, skills, and confidence, and empower every individual by transforming them into a proper, efficient engineer by providing all the knowledge and skills required. So these are the courses that we provide: design verification, design for test, physical design, analog layout, and embedded software. Okay, so first I'm going to answer about the courses that we provide: design verification, design for test, physical design, analog layout, and embedded software. Okay, so coming to design verification, as you can see, this is a design verification will come as part of the second stage after a RTL design engineer has written the code. Okay, so once the RTL design engineer writes the code, okay, in the Verilog, he will compile it for, let's say we are writing, we want to design some mobile SoC. Okay, this is Apple A14. Okay, or we can take any Samsung. This is Snapdragon, which is used in Samsung mobile. Okay, so this is some Thunderberry 5, which is equal to like Raspberry Pi or Arduino board that you guys have used in academics for embedded. Okay, so if you want to design any of these SoC designs, so for each like this is more clear for you guys. I'll just, for this is a Qualcomm Spectra ISP Arduino GPU. You have a graphic processor unit. Okay, you have sensors, sensing hub, processor security, CPU, cryo CPU, 5G modem, fast connect, and memories. So these are all the individual modules. So you have to write the RTL code taking each and every one thing as a module. So you separate entire SoC into blocks and subsystems. Okay, RTL design engineer will write the code. Once RTL design engineer writes the code, he will give that code to verification engineer to verify it. Okay, so verification engineer has to write the test case to verify that RTL module. Let's say module AND gate, module AND inputs and outputs and module. So this and there is a logic of AND behavior. Okay, C is equal to A and B. So this behavior of module, he has to verify. The verification engineer has to verify by providing test case or creating a test case. Okay, in such a way that stimuli and response has to be. We give the stimuli and verify the response using waveform. Okay, so this is the job of a verification engineer. So to write to design these test cases, verification engineers has to learn the SV system Verilog and UVM methodologies. Okay, so coming to this verification, as you can see, advanced Verilog concepts, advanced system Verilog concepts. Okay, DUT and test plan creation, because he has to test or that verify that particular module written by the RTL design engineer. Okay, so we take that entire module as a design under test. Okay, design under test, and test we have to create the test plan. Okay, we have a UVM, that is called universal verification methodology, that is used for this is all part of a proper way of scripting and assertions. So this is verification is entirely a different domain, and even RTL design engineer, system physical design engineer, DFT engineer, in-log layout engineer, all will communicate throughout the process of designing a chip, but verification engineer is entirely different. Okay, so we will not have much interaction with verification design engineer until unless we need some validation, or a we want him to validate or verify our design. Okay, so verification is that part, that the role of verification engineer is that. Okay, so he is responsible for the functional coverage also. That means how much of the total number of combination logic gates or sequential elements that you have in the design, how many of these logic gates you are able to test. That means you are able to 100% confirm that I'm able to give the input to the gate, and I'm able to get the expected output as per the truth tables of these logic gate elements. Okay, so this is the responsibility of a design verification here. Okay, this is clear. I'm going to DFT next. Okay, so DFT, I'm going to DFT because after verification, either you will get a RTL design to the DFT or a synthesizer netlist to the DFT. So there are two things. If you are getting a synthesizer netlist, that means not in a RTL format, it is converted into a gate level netlist. Okay, a proper netlist. So for that, either physical design team will do that synthesis, and physical design team will give us the netlist to the DFT engineers, and DFT engineer has to work. Okay, so there is a continuous interaction between RTL design engineer, physical design engineer, and the DFT engineer. So let me explain a little bit of what is DFT. So DFT is a design for test. Okay, so DFT responsibilities. Let's say I'll give a roundabout explanation with an example. Okay, so let us take this this itself. Okay, Snapdragon processor. So let's say this has been designed without any DFT, and it has come into market. Okay, and it is in the form of a mobile chipset. Okay, so this particular thing is in the Snapdragon. This is your Samsung mobile phone. Now after the user has started using the mobile, okay, he feels that there is a lot of heat dissipation coming out of your mobile phone. Okay, there are many glitches. Your sometimes your display is completely blacked out. Okay, or you're stuck while using games or camera or any application that you're using, and you feel that something is wrong with your mobile, and then you go back to where you buy it from, like the shop or the service center, right? So then what he says you need to you need this device to be sent back to the manufacturer and get it verified if you have it in the warranty. So they need to test it back to understand or identify what happened to this particular device. So to know that this particular entire device, this particular Snapdragon IC, need to be testable. Okay, if it is testable, then only you can able to test it. post manufacturing. Okay, so post manufacturing, if you want to debug diagnosis, okay, or refurbish an IC, you need testability. That means you need to add additional logic on top of whatever RTL design engineer has added. Okay, you need to add a logic that will give controllability and observability on each and every logical gates in the design. That is the work of a DFT engineer. Okay, so hardly 15 to 30% of what we call the additional logic, and that still that logic is added by the tool. DFT engineer will use certain mentor graphics or synopsis tools. Okay, and in our institution, we provide synopsis tools for DFT as well, and we insert DFT logic using the tools. So we don't need to write any RTL code. Okay, there is no coding involved in DFT or even the physical design. Okay, so DFT engineer has to use, he has to go through all these DFT methodologies, and he should be able to control the tool to perform DFT insertion and testing activities. That is the part of DFT. So these are all the boundary scan, the JTAG, ATPs and simulations are part of DFT required for testing and bringing testability to the design. Okay. So physical design, as Arushi has explained, we'll go with synthesis, pre-layout, STA, floor plan, power plan, placement, CTS, routing. Okay, and static timing analysis, IR and PV are part of this entire physical design, and these all are performed by the tool. Okay, so tool will provide you the manual, and seniors already existing in the seniors and architects already part of the organization. They will have a proper flow. Okay, how to utilize the tool and this manual commands and perform all these activities. So there is no coding as such involved in physical design also. A little bit of scripting that you will learn part of your course and while you work. Analog layout. So analog layout is completely analog design. These are also done using CAD tools. Okay, so the tools required for analog layout are different, which you might have seen in your academics also. Okay, so CAD tools are purely analog circuits, like analog transistors that you see, the resistors, transistors, all the physical analog components. Okay, that design is done by CAD tools and layout, and then provided to the CMOS fabrication. So even in analog layout also, CMOS fabrication is involved, because let me just show this. So if you see this, there are many analog components here. Okay, but very minute. Okay, so many analog components are here. The digital blocks are like this. Okay, this is flash storage. This is analog. Snapdragon is a digital IC. Okay, so there are many analog components that analog layout engineer has to work on. Okay, so that is the work of an analog layout design engineer. So that will be done parallel to physical design. So DFT, physical design, analog layout, all three will be working parallelly. Okay. So after physical design, the fabrication, packaging, and testing, these are also separate designations. Okay. Sometimes you can see physical design is one designation, physical verification and sign off is separate designation. Like it depends on the company to company. If they want to differentiate and have a separate team only for physical design, for physical verification, layout, post processing. Okay, that happens actually. Okay, so you can see all sorts of designations, and these are real-time designations. These fabrication engineers will work on fabricating. Okay, in the labs. So in India currently we do not have much labs. Okay, in Israel, US, Malaysia. Malaysia has 7 fabrication units of 7 different companies. Intel itself has 2 fabrication units in Malaysia. South Korea, and all the other countries out of India, we have fabrication units. In India, we are starting now. That I will explain what we are going to have it. So this is how it is in between the comparison between individual domains in semiconductor. Okay. If I answer this, I'm going to next on the placements and differentiation. Okay. So I wanted to show one thing which helps you guys understand the importance of semiconductor and the placements. Okay. So in the world currently, the only thing that keep on growing is this semiconductor, the technology. That means technology is still growing, right? So technology has to grow. That means you need an IC that can contribute to the technology advancement. So if somebody like software engineer has to design a software, it has to work on some. It has to be supported by an IC, the base IC. Okay, the server units. Okay, the data centers. Okay, anything that you want to do, you need an IC. Okay, if let's say at 2018 or of 2015 level, in the year 2015, we do not have much advancements as we have today. Okay, so a large amount of money and time is wasted in the R&D to bring the advancements. So this technology development is a regular process, and there will not be any recession in a technology development, particularly in the semiconductor. The recession we have is because of two reasons. One is uh, what we call the wars that are happening between uh, the Russia, Israel, and currently we have seen the Palestine war again. So, and the China and US trade. So these are temporary issues, and that has nothing to do with the uh, blockage of technology advancement. Okay, Samsung is releasing its own new advanced mobile. Apple is releasing its new advanced mobiles. Xiaomi is releasing its advanced new mobiles. So nothing has stopped. Okay, the hiring process might got delayed last year because of the COVID pandemic and these wars. Okay, but starting from November, I think this month, we are seeing that companies are started hiring. Okay, so companies started hiring starting from November. The what are the vacancies they have? They are getting filled again. The openings are started. Okay, so they cannot escape the. I mean, they cannot maintain recession. Something like software. If a recession comes into software, uh, technology advancement will not stop. Okay, but if recession comes into semiconductor, technology development will stop. Okay, so there will not be any recession in semiconductor as that you are seeing. Okay, it's a for a temporary period. They cannot continue this kind of uh, recession activity in semiconductor for longer time. Okay, so if they continue, you cannot buy a mobile phone, you cannot buy your car, because all your vehicles these days have advanced chips to control your motors and LCD displays, music system, and all the sensors in your car. Okay, so you cannot escape it. If you want to keep precision, your vehicles will not get booked. Your industry will suffer. Okay, so all countries are trying to come out of this recession, and this is happening since 1 year. Already we are in good stage now. Now the recession has stopped, and we are seeing hiring everywhere. Okay, this is the situation of what you're seeing in the recession. But unlike software, this is different. This is because of trade issues. That means if you have war between some countries or trade issues between some countries, what happens is you cannot ship ICs or parts that got manufactured in like say South Korea, China, Okay, so everything has to be shipped, right? So all the components has to be shipped through ships, large containers from one country to other country. Okay, so we cannot expect them to be delivered in time, having trade issues, right? So because of that, in last year, this year, we have seen some uh, issues. Okay, that got resolved now. There is no issue so anymore. There are no trade issues. Okay, if there are trade issues, we will not see Samsung S22, S23 Ultras, or iPhone latest model mobiles, or Xiaomi phones. So all you are getting from same South Korea or China, they are getting manufactured from Taiwan or Malaysia. They have to come through seaways only. If you have trade issues still continuing, you will not get these parts. You are using latest EV vehicles. Okay, so EV vehicles are entirely digitally designed. So you have a complete full and digital chips. Okay, even a small LED, for a small LED to work in your car, you need that part. Okay, so even that part has to come from somewhere manufacturing unit, Indonesia, Malaysia, China, South Korea, from this Asia itself. Okay, so now the things are better. It is improving. So as a enthusiast or people who are want to enter into semiconductor, it is there are many vacancies. Always semiconductor is full of vacancies because there are less people coming into semiconductor, even from ECE, triple core background people, because of lack of guidance. Okay, like institutions, we are now following up with the colleges and guiding the students to enter into semiconductor. But majority of the time, the campus placements happen with the software companies. They academic colleges or universities can bring only software companies. They're easy to get, so even EC guy or a triple E guy get placed in the software company. Okay, so that is the backdrop, and we have a very high openings, very high. We need a lot of engineers. I am with close to 15 years of experience in the semiconductor industry. I'm a DFT architect. Okay, so I am seeing a lot of what we call racks open. Racks open in the sense I have a lot of openings in our teams, but we don't have engineers. And in semiconductor, there will not be again special training given to the new joinees in the semiconductor companies. There will not be any training. You have to come trained. That is the reason these institutions like the market in the Maven or any other institute, like you can see there are many institutions in India, and along with the success page. Okay, we are all trying to guide you guys, train you, and if you are trained, you are eligible for openings into the semiconductor company. So if you are taking 4 months or 6 months course, by that time market will be very good. Unlike software, semiconductor recession doesn't stay for long, as I said earlier. The only recession we had because of trade issues, and that is resolved now. We do not have any trade issues now. We have very good openings, and the reason for more openings in India, okay, is because we are no longer dependent on other countries. We have in-house manufacturing units that are getting developed in Gujarat, Chennai. Apple, this latest Apple ICs, I mean Apple mobile phones are manufactured within India, and Xiaomi has many assembling units within India. Okay, so there are many openings happening within India because India is going to become the semiconductor hub. Okay, so you know that already government has uh, provided funding for a semiconductor, right? So everybody know that, right? So I do not have that image as of now. I want to show that. Okay. As of now, I do not have that image, but you can see the semiconductor funding is happening huge. I mean, the huge funding happening, like 75,000 crores of investment into semiconductor, and many companies already started. Even Micron got permissions to start its fab within Gujarat. There are many companies that are happening within India.